Hi everyone, my name is Leonard and welcome to Datature Tutorials. Today we're going to be training a keypoint estimation model. In general, keypoint estimation models are used to detect specific points of interest in an image. In our project, we want to use keypoint estimation models to pick out human joints as well as the golf club face in order to improve mechanical efficiency in a golf swing. To get started with this project, we first need to upload the relevant data, which would be any videos or images of a golf swing. So we can go on and select the dataset page on the left. You can upload assets in a variety of ways with the rectangular box above or with external buckets. As you can see, we've already uploaded a few assets in this project. We see 6 assets in this case, but some are images and some are longer videos which contain multiple frames. So this will allow us to train a model even though the number of assets in itself looks smaller. This image here is unannotated, so what we'll have to do is go ahead and annotate that image with a skeleton. To get started with annotation, we first need to create our custom skeleton. We already have one, but to demonstrate how to create a custom skeleton, we can go ahead and select the edit button on the right and then select to create skeleton. Once we've selected this button, we enter a skeleton editor where we can create a name for the skeleton. So I might say golfer, and then we can add key points and edges as needed in order to represent the various kinds of points of interest that we are looking to detect. So now I will be creating a skeleton which contains a variety of human joints as an example. So we can also connect these points up so that the visualization is clear on the annotator to see how each of these different key points are connected. So I'll go ahead and connect up these dots. It's also important for us to have some sort of semantic knowledge about the meaning of each of these key points. So it's good habit to edit the labels for the individual key points and label them with their meaning. So I'll go ahead and label each of the joints with their corresponding names. So head, chest, left shoulder, right shoulder, etc. Once I've finished editing all the labels, we can now also change the color of the skeleton to make it look differentiated from other skeletons that you may have in the project. So I'll change it to red, and then we can save the skeleton and go ahead and proceed with annotation. In our case, because we already are looking at a specific type of skeleton, which is this golfing context, I've gone ahead and created a skeleton beforehand, which we can take a look at here now. And as we can see with this skeleton, there are a few different points, such as the neck and the club key point, which are more relevant to our context, which we will need for annotation. We'll now go ahead and annotate with this previous tag, human. What we have to do is to draw the skeleton using the draw tool, and we'll click and drag and initiate a skeleton. From then on, we should select the skeleton and then adjust the individual key points to match where they would be on the golfer. So we would move the right foot point over the right foot of the golfer, etc., and keep doing it until we are satisfied with the quality of the annotation. So now that we've annotated the image, we can see that we've also annotated a few other assets in this project, so we can go ahead to train the model. To get started with that, we should go to the workflow page and create a workflow. We can select key points as our objective. In this case, because golf is a real-time sport and we want real-time feedback, in order to determine how good a swing is, we want the fastest inference speed and the smallest model in order to deploy it on the relevant devices and achieve our goals. Now that we've created a workflow, We can go ahead and edit the various hyperparameters if needed, so the dataset page or augmentations. So for augmentations, we might want to add some brightness and contrast because golf is played outdoors and different lighting can affect the way that the video is recorded. So we want to be accounting for that when we're training the model. Also, we might want to add motion blur as a way to account for the swing. Finally, we can also go ahead and edit any model hyperparameters such as the number of training steps. We might want to change it from 5,000 to 3,000 given the smaller dataset that we're working with. Once we're happy with the setup, we can just go ahead and select Run Training. Here we can select our checkpoint strategy. So we want to go for highest accuracy in order to ensure that the checkpoint that we save is highly accurate, and we'll alter the evaluation interval to ensure that it's practical for the amount of time that we want to train for. We'll also train on Datature Cloud with a T4 GPU, and then we can go ahead and start training. Let's jump to a training that is already completed. As you can see with this training run, we can see the loss metrics, which might be useful for determining whether the training has gone well quantitatively. We can also look at our advanced evaluation to determine whether the model is accurately predicting the different key points and human joints in our images. And we can see as the training progresses, the model is able to pick out the correct key points that we need it to. So the model seems to have trained well on this dataset. With that in mind, we're able to go ahead and export the model and perhaps use it in production. In order to do that, we'll go to the artifacts page and find our relevant artifact, which is the one that was saved from that training earlier. And we can go ahead and either export the model or create a deployment. In our case, because we want to run this real time, we'll go ahead and export the artifact. Artifact export supports a few different frameworks, such as PyTorch, Onyx, and TensorFlow, which will allow you to deploy your model in various contexts and ultimately allow you to use your model to predict the golf poses and human joints throughout a swing in order to allow you to improve the general mechanics of your golf swing.